beautiful people, and welcome. In today's video, we're going to talk about parent functions and do some examples about transformations. If you have not already watched the graphing organizer video for transformations of functions, please make sure you have watched that video. So that way you have created your own graphic organizer. We will be referring to that graphic organizer in this video. As always, if I make a mistake, please let me know where the mistake occurs so that way I can learn from my own mistakes. All right, beautiful people, let's get started. So I want to start out this video with identifying parent functions. You're going to hear parent functions a lot. We're going to start out with quadratics, then we're going to move to cubics in our units, in our modules. However, all of these are going to come up in graphing transformations. So how to determine what a parent function is. So a parent function is without any transformation. So nothing happens. So for example, in our first parent function, we have x squared. So in x squared, how did I figure out what I'm typing or what I'm graphing is I'm taking my pretty points. So when you hear pretty points, these are the points that I'm referring to. And typically for pretty points, you want at least 3 pretty points. And those pretty points tell you the overall shape of what you're working with. For example, if I was to plug in -1 in for x and square that, -1 squared is 1. So I have my input as -1, my output as 1. If I do the same to 0, I get 0. And if I do the same to 1, I get 1. So here are my 3 pretty points. I want my input and my output to be pretty. If I wanted to do a 0.375, I could. However, it's not pretty. 0.375 is definitely not a pretty value, and your output definitely wouldn't be a pretty value. So we want pretty points. So here are they're also called reference points. When you see reference points, those are pretty points. I just like the word pretty. These are my pretty points, and if you're in my class, we will be talking about pretty points a lot. I did the same thing for another parent function. So here's your parent function. One thing you guys I didn't mention is you have to know these. You have to memorize these. Okay, so make sure you're writing this down on your notes. I would attach this parent function sheet to your graphic organizer for transformations. So that way you have it. So if you get lost into how this graph should look like, here it is. Here's another one, cubic. So x to the third power. I did the exact same thing. I plugged in values for negatives. Excuse me, I plugged in values for x, and I got -1 and -1. I plugged in values for y, and I got these values here. Now, this one here, we call it a John Travolta. If you're in my class, you're going to know why we call it John Travolta. If you're in my class and you still don't know, you will know why we call this a John Travolta. So this is Mr. John Travolta. The next parent function you're going to be coming across is a absolute value of x. Now, absolute value of x, look at actually, let's look here. Look at our pretty points here for my quadratic. So my x squared, look at these pretty points, and then look at the pretty points for my absolute value. Notice that they are the same. So don't rely just on your pretty points to know how a function will look like. Make sure that you all are aware that an absolute value is a V shape, and this one here, I call it a happy face shape for a parent function. Next one you're going to come across is a square root. Square root, it has a does not exist. For anything less than -1 or -1, it can't have a negative value. You can't take a square root of a negative value. So we only have two reference points or 2 pretty points. I have 0, 0 and 1, 1 as my 2 pretty points for my for my square root function. Now, that is a little different for my cube root. We can have negatives for cube root. This is how the parent function looks like. Here are my reference points again. You must memorize how the parent function looks like, because with transformations, just like you look very similar to your biological parents, our transformations, our transformed graphs will look really similar to their parent function. Now, it's going to be different. You might look different than your biological parents, but you do have some similarities. Same thing here. Our transformed graphs will have some differences, but it's still going to look like the parent function. All right, let's go ahead and jump into some examples. Make sure you have this drawn out and connected to your cheat sheet for your transformations. All right, let me actually get some more paper here. Running pretty low. All right. Some examples. For these examples, all we're going to do is translate. So when it's asking you to translate this parent function, what is happening? We're just going to write using English words what is happening. Notice that this is outside the bubble. So here's our bubble. Bubbles are parentheses. It is outside the bubble. Anything outside the bubble is a vertical change outside the bubble. So that means we are going up by 2. How is that changing our values? You can say up by 2. You can also say vertical shift 2, up 2. There's different ways. Up by 2, I'm okay with just up 2. When it comes to a test or something, I'm okay with up 2 even. Mathematicians are lazy. You don't have to use too many words for outside the bubble here. This one here is also outside the bubble. 3. We're multiplying our function by 3. Outside the bubble means you have a vertical. Outside the bubble means you do what it looks like. So if this is multiplied by 3, when you multiply something, the value gets bigger. So vertical stretch by 3. Now, this is not, we're shifting up by 3. That's different. There is a vertical stretch. You can say by a factor of 3. Factor means you're going to multiply. So you can say vertical stretch by a factor of 3, or you can say vertical stretch by 3. I'm okay with either. This one here, this one says I have a negative times x plus 1 squared. We'll be careful. So this here, what is our parent function? Look at what we have. We have a 2 and we have an x. So parent function is x squared. And so what is happening? Let's translate this. The first thing I see is I see a negative. So I know I have a negative on the outside. So outside bubble. Now this is not the actual translation. This is my work. I have an outside bubble, a negative. I have an inside bubble, plus 1. And then I just have the squared. Now the squared belongs to the parent function. Notice that here's my parent function. I had to expand my bubble. Here's my bubble. I had to expand my bubble to put my plus 1 in it. And then outside of the bubble, I have my minus 1. So if you have outside the bubble, remember the change is vertical. And outside the bubble negative means you have a reflection across x-axis. Inside bubble, think opposite. Remember, opposite of what it looks like. Opposite and horizontal. So if it looks like horizontal plus 1, it is a horizontal shift. Which direction? If I see a plus 1, that means I'm going to the positive ones? No. Inside the bubble, you're thinking opposite. So if you see a plus 1, you're in fact going to the negatives. You're going toward the left, 1 jump. Or you can say shift to 1. So let's actually graph this one. Let's graph the parent function and let's graph the transformation. So I actually will be graphing both on the same axis. So parent function, again, you want your pretty points. So what is for the parent? We said the parent function is f of x is equal to x squared. So for x squared, here's our t-chart. We have 3 pretty points for x squared. Again, you should be able to see this on your reference sheet. So we have negative 1, 0, and 1. And we have 1, 0, and 1 for my y values. Here's 1, 1, here's 1, 1. And here's my parent function. Now we're going to do exactly the same thing, but for our transformed function. So for our transformed function, let's call it g of x. You can do this 2 different ways. So if you look at your transformation function cheat sheet, you're going to notice that things are happening. So I have one here. So things are happening. I am inside the bubble. So I'm looking for inside the bubble. There it is, inside the bubble. I have a plus, so that means I am subtracting h from my value. And then I have outside the bubble Outside the bubble, that means I am flipping it. So you can do this with your actual numbers. However, I think it's easier if you just use your pretty points and shift it that way. For example, our original points are -1 and 1, 0 and 0, 1 and 1. So what is happening to those points? So we said that for our b, because we have a negative on the outside, b becomes negative. So let's see here. What is b? Here's my x values. I'm going to call them new. Here's my y values. New. B is my y. So I'm going to say I need a negative on my y. Okay, and then what did we say? We said that that's reflecting. So now we have the opposite of +1. I have a +1 on inside the bubble. +1 inside the bubble. So I'm looking for inside the bubble plus, there it is. And so here's my x value. A is x value. And so I'm subtracting by my h. So here it is, and I'm going to subtract by my h value, or in this case, by 1. So for my values, I have a formula now. I have x minus 1, and then here I have negative y. So that's my new formula. You guys can't see that, I'm sorry. That's my new formula for what I'm going to be plugging in. So what is x? X is -1 minus 1. What is x? X is 0. What is x? X is 1. So I'm plugging in my pretty points here and finding out what my output is. So I have, for y's, I have -1, -0, -1. So how do I make this prettier? Let me simplify this. So here's my new x's, here's my new y's. So -1 minus 1, that's -2. 0 minus 1 is -1. And 1 minus 1 is 0. This one here, we're just reflecting, so I have a -1, 0, -1. So these are now my new points. This is for the transformed function, my new pretty points. So how did I do that? I just want to tell you guys again. I translated using words what I did. I reflected, so I flipped it over, and then I took one jump to the left. So with my points, I flipped it over, and I took a jump to the left once. So let's do that. Flipped it over and jumped to the left once. So if this is my 0, 0 point, I'm going to flip it over. 0, 0 still stays at 0, 0, and I jump once to the left. So I should have a point at -1, 0, and I do. Next one, here's my other point. I'm going to flip it over. So now I am at -1, and I'm going to take one jump to the left. So I should be at 0 and -1. I do have a point at 0 and -1. Here is my point. I'm going to flip it over. So I'm here at -1, but I'm taking one jump to the left. So I should be here. So here's my parent function, f of x. Here is my transformed function, g of x. All right, let's do one more example. These are, I can't stress this enough, you guys. Just practice, 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 practice. It is so important to practice these things. The more practice you do, the easier this stuff becomes. And you're going to need to know this for all eternity while you are in math class. You keep doing it over and over and over. All right, let's try another one. So this one's just saying sketch the graph of each function. So let's do f of x is equal to, trying to find a good one, you guys. Let's see here. So you know what? I think I have a good one. Trying to find a really good one for you guys, I promise. Oh, I don't know. Let's do this one. Let's do this one. X I'm going to make one up, you guys. Let's just make one up. Let's do a quadratic to make it easier. So let's do 3x squared minus 4. Let's do everything outside the bubble in this example. So the first thing you need to determine, do you have a negative? You have a 3 and you have a minus 4. So it's positive, so no reflection. So you stay in. You have a 3 outside the bubble. Here's your bubble. X is your bubble. You have a 3 outside your bubble. So you're going to vertically stretch by 3, by a factor of 3. Then you're going to say you have a negative 4. Again, it's outside the bubble. Outside the bubble is always vertical, and it's always what it looks like. And this is left. Ooh, excuse me. This is down 4. If you'd like to draw the parent function, you can. You can always do this as well because we want our original points, our pretty points, and we want our transformed points. So we have -1, 0, and 1, and we have 1, 0, and 1 as our original pretty points. Let me switch this in. Those are our original pretty points. Now, what is happening? Well, there's no reflection, so I don't need to multiply by a negative on anything. Vertical stretch by 3. Vertical means up and down, so what's changing? X or Y? That means my Y is changing. And so if I'm changing my Y by a factor of 3, that means now I have 3Y. And not only do I have 3Y vertically, I also have down 4. That means I have down 4. So although my X, my horizontal, doesn't change, a lot is happening to my Y. So I have still -1, I still have 0, and I still have 1. Now I'm taking my Y value and I'm plugging it in. All of my Y values. And so that's what's happening to each point. I know you guys, this is a lot of work, but trust me. Trust me. With practice, it gets easier. So -1, 0, and 1. So 3 times 1 is 3. 3 minus 4 is -1. This is 0 minus 4 is -4. This is 3 minus 4, -1. So now that you have your new transformed points, we're going to graph these. So I have -1 and 1. Excuse me, -1 and -1. 0 and -4. And I have 1 and -1. And we only need 3 points, you guys. As many pretty points as you need. You don't go overkill. You can have an infinite amount of pretty points. Let's just not do that. So here is our transform graph. So I'm going to just do a quick dash line. This would be our parent function. So what happened? We shifted it down 4 and we stretched it by 3. Okay, we vertical stretched it by 3. So we went this way. We made it bigger. That was our original, would be here and here. Here and here. All right, let's do one more example. So I don't want this video to be for too long. And again, let's make one up. Let's do a quadratic just to make it easier. Let's do f of x is equal to, let's not do that. Let's do f of x is equal to inside the bubble now. Let's do x minus 5 squared. Let's times that by 3, and we're going to do, oh, let's do outside the bubble too. Oh, too many 3s. Too many 3s. Let's do 1. Again, so how do we do that? Each number that you see, you need to identify. And now you also need to identify the sign. So if 3 was negative, you'd have to identify that and you'd have a reflection. But this doesn't have a negative, so you don't have to identify it. So I have 3. 3 is outside the bubble, so that means I have a vertical. Vertical means you do what it shows you. So if I have a 3 times, that means I have vertically factor of 3, meaning I multiply by 3. Vertical stretch by 3. So then I have a minus 5. Inside the bubble, you think opposite. So if you see a minus 5, that means you're going to add 5. So you have a horizontal not stretch. We have a horizontal shift. And we're shifting to the right. by 5. Now I have outside the bubble. Outside the bubble is always vertical, and I'm doing what it's telling me. I'm adding 1, and that means I'm going up 1. So again, let's do our pretty points. Here's our original parent. I know my parent is x squared because I'm looking at the symbols. So I have, what do I have? -1, 0, and 1. I have 1, 0, and 1 as my pretty points. Now I need to create my formula for what is happening. So what is happening? I do have a horizontal. Horizontal means x, and I am shifting right by 5. So if you shift right by 5 and x, you're going to have to add 5. I have a vertical up 1, so I know I'm going to add 1 to my y's. And I have a vertical stretch by 3. So very similar to what we had last time, we're going to multiply y by 3, and we're going to add 1. So what's happening here? I'm taking my x value, -1, I'm going to add 5 to that. Taking my x value 0, I'm adding 5 to that. Taking my x value 1, I'm adding 5 to that. Now again with this formula, taking my y value 1, multiplying by 3, adding 1. Taking my other y value, I've created my formula by translating my transformation. My function, I translated this, I've created my formula, and now I'm doing this. Yes, there are other ways to do it, you guys, but this way you know exactly what's happening to one point. So if I ask you on an assessment or a test, what is happening to each point, you can tell me that for my x's, I'm adding 5 to each point. I'm shifting at 5. For my y's, I'm multiplying by 3, adding 1. So let's do our new x and y values. So I have 4, I have 5, and I have 6. Then here I have 3, 4, I have 1 and 4. So how would this look like? Again, how does the parent look like? The parent looks like, this is the parent function. Do a quick sketch. That's the parent function. So now we're looking at these points. This is 1, 2, 3, 4, 1, 2, 3, 4. Here's 1 point. 5 and 1, 5 and 1. Ooh, let's enlarge this. 5 and 1, there it is. And 6 and 4. And this is our transformed function. So you can see how the parent function got stretched out and it got shifted up 1 and it got shifted to the right 5. All right, beautiful people, this wraps up this video. Again, practice, 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 practice. And when you're done with that practice, practice some more. I can't stress that enough. This stuff is difficult. We will use this entire school year and in pre-calculus and in calculus. Everything, transformations follow you. All right, that is it. Thank you for watching this video, and I will see you in my next one. Goodbye.